The Chinese continue to make some spectacular gains out in outer space. Today, sending back some spectacular high-resolution panoramic views of the surface of the moon. That is, the far side of the moon, little seen by man.
China just released footage from the far side of the moon. Not a photograph, not a simulation. Actual descent camera footage from a landing no other country has ever attempted. And what the cameras captured should not exist. The soil was darker than anything in the Apollo archives. The minerals were wrong. When researchers in Beijing opened the sealed container and ran their first analysis, one scientist sat in silence for nearly a full minute. Because inside that dust were structures that should only form inside billion-dollar laboratories.
What researchers found within the dust was completely unexpected. Graphene, a material that has never before been detected naturally on the moon.
Carbon sheets only a few atoms thick. Graphene, manufactured by nothing more than 4 billion years of cosmic violence on a world with no atmosphere, no chemistry, no life. And that was just the first layer. Buried deeper were traces of water on a world born from fire. Evidence that the moon is two completely different geological bodies fused together. And mineral fingerprints from an ocean of magma that burned before Earth had stable oceans. The far side kept all of it hidden. Until now. 15 minutes of silence. Hu Hao, chief designer of the Chang'e 6 mission, had spent years preparing for a moment he could not control. His team at the China National Space Administration had rehearsed every failure scenario they could imagine. They had mapped terrain they could not fully see. They had built a lander smart enough to think for itself. But when that lander began its final descent toward the far side of the moon on June 1st, 2024, Hu Hao could only watch. Here's the thing. The far side of the moon is not dark. It gets just as much sunlight as the side we see every night. But it is unreachable by radio. The moon itself is a wall of rock 2,000 miles thick, blocking every signal between Earth and the hidden hemisphere. China had launched a relay satellite called Chang'e 2 to bridge that gap. But during the actual landing, even that bridge could not keep up. For 15 minutes, the spacecraft was completely alone. No commands, no corrections, no human hand guiding the descent. And get this. In the control room at the Beijing Aerospace Control Center, screens showed trajectory data updating in delayed fragments. Each number was already history by the time it appeared. Hu Hao watched the altitude fall. 8 kilometers, 5, 2. Boulders the size of cars littered the approach zone. Craters overlapped craters, each hiding terrain the cameras could not fully resolve. The lander's AI scanned the surface in real time, rejecting unsafe zones, adjusting thrust, choosing stability over speed while fuel burned away and gravity pulled harder. Then dust thrown up by the engines blinded the sensors entirely. The low gravity made every movement unpredictable. A small bounce could tip the spacecraft. A wrong calculation could end the mission. One mistake. That was all it would take. The control room went quiet. Not the quiet of concentration. The quiet of people holding their breath. Hu Hao had run more than 1,000 simulations of this moment. He had wargamed every failure scenario. But simulation and reality are not the same thing. In simulation, you can pause, you can rewind, you can fix what went wrong. On the far side of the moon, there is no rewind. There is only the next second and the second after that, and a machine making choices at a speed that no human brain can match. Then the signal came through. Contact confirmed, legs down, stable. Hu Hao exhaled. The South Pole Aitken Basin remained silent, but humanity had just touched ground inside the largest, deepest, and oldest impact scar in the entire solar system. A wound stretching over 1,500 miles across, punched into the moon more than 4 billion years ago, by a collision so violent it nearly cracked the world in half. And 53 days later, when the return capsule parachuted into Inner Mongolia, carrying 1,935 grams of lunar material, the real mystery was waiting inside. But first, a single observation about the color of the dust would shatter a question scientists had been arguing about for decades. 2 moons in one. Li Chunlai was among the first to see it. As deputy chief designer of the Chang'e 6 mission and a senior researcher at the National Astronomical Observatories of the Chinese Academy of Sciences, Li had helped plan this moment for years. He expected pale dust, the kind Apollo astronauts had tracked through their lunar modules. Gray, ashen, familiar. What he saw instead made him stop. The soil was darker, noticeably, unmistakably darker than anything returned from the near side. And it was looser, more porous, almost fluffy in its natural state. Li's team published their first analysis in the journal National Science Review, and even in the measured language of a peer-reviewed paper, the implications were staggering. Here's what most people have never been told. Look at the moon tonight. Those dark patches you can see with your naked eye are called Maria, ancient seas of frozen lava that spread across the near side billions of years ago. Molten rock erupted from deep inside the moon, cooled into smooth plains, and left those dark stains that humans have been staring at since the beginning of civilization. But the far side has almost none. It is brighter, rougher, covered in craters piled on craters with no volcanic floods to soften the landscape. For decades, scientists could describe this contrast, but they could not explain it with direct physical evidence. They had theories, they had models. They had never held the far side in their hands. Chang'e 6 changed that overnight. Now, pay attention to this part. The data from those samples revealed that the moon is not one world. It is two completely different geological personalities fused into a single body. The near side had higher concentrations of radioactive elements, potassium, rare earth elements, and phosphorus, collectively called creep. That radioactive heat kept the interior fluid. Magma stayed molten. Lava punched through the thinner crust again and again, painting the dark Maria that humans recognize when they look up at night. The far side told a completely different story. Its crust grew roughly 20 kilometers thicker. Its interior ran cooler by hundreds of degrees. The magma could not break through that lid. When Li Chunlai's team compared the geochemistry of the Chang'e 6 far side samples to the Chang'e 5 near side samples, the numbers confirmed what orbital data had only hinted at. 2 hemispheres, 2 thermal histories, 2 moons wearing one face for 4 billion years. Li Chunlai later described this moment with characteristic understatement. In the official SCIO briefing, his team stated that the samples exhibit distinct characteristics compared with previous lunar samples. But behind that careful language was a revelation that rewrites how we think about every rocky body in the solar system. If the moon can be this fundamentally divided, this geologically schizophrenic, then what does that say about Mercury, Mars, the moons of Jupiter? And here's what makes this even stranger. The samples contain basalt fragments dating back 4.2 billion years, the oldest creep-rich basalt ever found anywhere, alongside younger fragments from 2.8 billion years ago that were nearly devoid of creep. That means the source of the magma underneath the far side fundamentally changed over a span of 1.4 billion years. Something shifted deep inside the moon's mantle, and no one fully understands what triggered it or when it stopped. That discovery alone would have justified the entire mission. But what was hiding deeper in that dust made the dual hemisphere finding look like a footnote. If you think 2 moons in one body is hard to believe, wait until you hear what else was hiding in that ancient soil. Subscribe now so you don't miss what comes next. Carbon from chaos. Professor Wei Zhang at Jilin University was not expecting what his microscope showed him. His team had been analyzing lunar samples using a battery of advanced techniques: scanning electron microscopy, Raman spectroscopy, transmission electron microscopy, and compositional mapping. They were looking for carbon signatures. What they found made Zhang pause, rerun the analysis, and call in colleagues from the Chinese Academy of Sciences Institute of Metal Research to verify independently. Graphene on the moon, formed naturally, without factories, without engineers, without human hands, by nothing more than 4 billion years of cosmic violence. Carbon arranged in sheets only 2 to 7 atoms thick, wrapped around mineral grains like delicate crystalline shells. Zhang stared at the Raman spectroscopy results. Then he checked the scanning electron microscopy, then the transmission electron microscopy. Every instrument told the same story. the same material that costs thousands of dollars per gram to manufacture on Earth, that requires sterile laboratories, controlled temperatures, and precise chemical vapor deposition processes, was sitting in lunar dust, fully formed, waiting to be found. Here's the catch. The moon has no atmosphere, no factories, no biological processes, no chemistry as we understand it. There is no known mechanism that should produce graphene on a dead, airless world baked by solar radiation on one side and frozen to -280 degrees Fahrenheit on the other, unless you count raw violence. Every single day, the lunar surface is bombarded by micrometeoroids traveling at tens of thousands of miles per hour. No air slows them down. Even grains smaller than a pinhead deliver enormous pressure for a split second when they strike rock. In that instant, carbon atoms in the soil get squeezed, superheated, and forced into new crystalline arrangements. Then they cool so quickly that the structure locks permanently in place. But here's what nobody is talking about. Chang'e's team proposed a second formation pathway: iron-bearing minerals in the soil. Catalyzed by solar wind interactions during the moon's early volcanic era, acted as natural factories. The iron drove a mineral-catalyzed process that converted carbon into high-quality graphene without any human engineering. Chang'e called it a potential paradigm shift in carbon science. His team published their findings in the journal National Science Review and the journal Nanoletters. And they did not stop at graphene. Deeper in the samples, Chang'e's group confirmed the existence of naturally formed single-walled carbon nanotubes. This is a material that, on Earth, remains one of the biggest manufacturing bottlenecks in advanced materials science. Teams of engineers in the most sophisticated labs on the planet struggle to produce carbon nanotubes at scale. The equipment is expensive, the yield is low, the quality is inconsistent, and yet the moon has been doing it for free, in total silence, for billions of years, using nothing but iron catalysts, solar wind, and the relentless percussion of micrometeoroid impacts. So here's the deal. If graphene and carbon nanotubes exist naturally in lunar dust, then that dust is not waste. It is not an inconvenience to be swept off spacesuits and cursed at. It is a strategic material, lightweight composites for spacecraft hulls, protective coatings for habitat walls, conductive materials for electronics, batteries, sensors, and power systems, all harvestable from the ground beneath an astronaut's boots. The far side of the moon was not barren. It was a materials factory that nobody recognized for 4 billion years. But the graphene was not the strangest thing hiding in that dust, because the next result made the entire team question everything they thought they knew about how moons are born. Water in a world of flames. Here's the thing about the moon's origin that most people learn in school and then never think about again. More than 4 billion years ago, a Mars-sized object called Theia slammed into the young Earth at a speed that defies imagination. The collision threw molten debris into orbit. That debris gathered, cooled, and became the moon. The entire moon started as an ocean of magma, a globe of liquid rock, hot enough to vaporize anything volatile within 1 million miles. Chang'e 6 brought back proof. The soil contained mineral fingerprints that could only form if the entire world had once sorted itself like a liquid. Heavy minerals sinking toward the core, light feldspar crystals floating upward like foam on a burning sea. An ancient ocean of fire slowly freezing into the bright highlands we see today. And here's the part that should stop you cold. A world born from that kind of fire should be bone dry. Every molecule of water should have been vaporized in the first million years, gone, irreversibly. When scientists first proposed looking for water in the returned samples, some of their colleagues were skeptical. Why waste time looking for something that physics says cannot be there? But that is not what they found, and this is where it gets unsettling. Researchers analyzing Chang'e 6 impact glass beads, tiny spheres of glass created by micrometeoroid impacts, found water locked inside them. Solar wind hydrogen bonds with oxygen atoms in the glass, and the beads act as sealed reservoirs. A team publishing in Nature Communications measured water abundances ranging from roughly 10 to over 1,000 micrograms per gram in the far side beads, with unmistakable solar wind hydration signatures. Now, here's the crazy part. The far side beads had strikingly shallower hydration depths compared to near side beads from Chang'e 5. The moon's water signature is not uniform. It is a patchwork. Some regions hold onto water like sponges, others barely retain it at all. The geological history of the surface, the grain size, the glass content, even the time of lunar day determines how much water the soil can store and release. At local noon, when the surface temperature peaks, hydration. Signatures dip as the heat breaks molecular bonds. By evening, as temperatures plunge, the hydration rebounds. The regolith breathes water in and out like a molecular tide. Nobody predicted that. But the water story does not end there, not even close. In a separate discovery from Chang'e 5 samples, scientists found a hydrated mineral crystal they designated ULM1. This mineral contains over 40% water by weight. Not contamination, not spacecraft residue. Actual lunar crystals holding water molecules in their atomic structure, stabilized by traces of ammonia that keep the H2O intact despite wild temperature swings. And in yet another finding, researchers identified fragments of carbonaceous chondrite in Chang'e 6 soil, the rarest type of meteorite, representing less than 1% of all meteorites found on Earth. These asteroids are incredibly porous and loaded with water-bearing minerals that make up as much as 20% of their mass. On Earth, they usually disintegrate in the atmosphere before reaching the ground. Finding one preserved on the lunar surface, where there is no atmosphere to destroy it, means water-rich asteroids have been delivering volatile materials to the moon for billions of years, and the evidence survived impact. The researchers confirmed the identification using advanced microscopy and isotope analysis, matching the unusual chemical ratios to known Ci chondrite signatures with high confidence. So, basically, here is what this means for the future. Every liter of water launched from Earth to the moon costs thousands of dollars in rocket fuel alone. If water can be extracted from glass beads, mineral crystals, and preserved meteorite fragments already sitting in lunar soil, the entire economics of space exploration inverts overnight. Future crews will not need to haul their water supply from Earth. They will need industrial equipment to bake it out of the ground. The barrier is no longer impossible delivery. It is engineering, and that is exactly what China is building toward. The race for the far side. Here's what should keep every space agency on Earth awake at night. China is not treating these discoveries as academic curiosities. They are treating them as a resource map. Chang'e 7 is scheduled for 2026 to survey for water ice near the lunar South Pole. Chang'e 8 follows in 2028 to test in situ resource utilization, which means extracting and processing materials directly from lunar soil on site. The endgame is the International Lunar Research Station, a permanent robotic outpost at the South Pole, with crewed landings planned before the end of this decade. Now, think about what that means in light of what they just found. Graphene and carbon nanotubes for advanced manufacturing, water for life support and rocket propellant, building materials already embedded in the soil, a factory floor that nobody has to build because the moon built it 4 billion years ago. Here's what nobody is talking about. Whoever controls access to these resources does not just lead the next chapter of space exploration. They define the rules, they set the terms, they decide who gets to use the moon and who does not. NASA Chief Bill Nelson has publicly flagged China's lunar activities as the opening moves of a new space race. During a congressional hearing, his concern was blunt. If China establishes a permanent presence at the South Pole first, they may attempt to restrict access, treating lunar territory the way they treat contested waters in the South China Sea. James Head, a research professor emeritus at Brown University, who collaborated with Chinese planetary scientists on Chang'e 6 analysis, has described the pace of China's program as methodical and relentless. And consider the timeline. The United States has not landed a human on the moon since 1972. NASA's Artemis program has faced repeated delays. Meanwhile, China has soft landed on the far side twice, returned samples from both sides of the moon, and is building the infrastructure for permanent habitation, while other nations are still debating budgets. The samples from Chang'e 6 are not just scientific trophies, they are proof of concept. Proof that the moon holds what humanity needs to sustain a permanent off-world presence. Graphene for technology. Water for survival. Ancient geological records for understanding our own origins. And right now, only one country has touched the far side, returned its secrets, and started building the road back. What the far side knew. Nearly 2 kilograms of 4-billion-year-old dust now sit in laboratories across China, with international researchers lining up for access that may take years to receive. Inside that dust is evidence of 2 completely different moons sharing one body, a split personality hidden for longer than complex life has existed on Earth. Carbon nanostructures born from billions of years of silent violence that humans pay fortunes to recreate in clean rooms, and still cannot match. Water hidden in glass beads and crystal lattices on a world that should be completely dry, delivered by some of the rarest asteroids in the solar system. And mineral fingerprints from an ocean of fire that burned before our planet had stable oceans. Every one of these discoveries came from a single landing site. One crater inside one basin on one hemisphere of the moon. There are millions of craters on the far side that have never been sampled. The far side kept these secrets for 4 billion years. Silent, patient, waiting. Now the question is not what China found. The question is what they haven't told us yet, and what will be waiting in the next container they open. Subscribe and hit the notification bell. You'll want to be here when the next sample opens.